So since this is accumulation and I wasn't here last week of all the previous classes, I'm going to spend a bit more time on reviewing and then make sure if you guys have any questions to just talk to me and then I'll help you explain the way through it. So we're not on Pear Deck today because most of the assignments are going to be at the end. If you want to program along with us and learn that way, so you can go through your browser and type on a free online Python compiler. Then you can choose one of the links. So here I use this one. Let me delete this stuff here. You can write code in here and then run your code over here. This way, you can just code along with us, and that makes whenever you write your assignments, you can put it on here. Okay. So here's a group me, here's a Google Classroom. Since it is like the last couple of days, there won't really be too much in there, but still, you guys can join that if you feel free. You can feel free to join that if you guys feel like so. Okay. So now we're going to do some review. So here's a couple things that we specifically did. So the first couple classes, a print statement, remember to print and followed by parentheses. And then whatever you want to print out inside. The two ways to comment, you can do a single line comment with the hashtag #, and you can use multi-line comments. So everything within these three asterisks, or sorry, these three apostrophes becomes a comment. So you can comment multiple lines. Next, some variable assignment and variable expression statements. So remember, to assign a variable, you need to first call the name of the variable you want to. So in this instance, I just called the variable, used an assignment operator or an equal sign equals to some value. So all this to say is that variable is equal to 10. So, and then in the future, you can modify this and call this value of 10 by referencing variable using, and also to modify them, you would use the assignment, the different expression statements right here. So variable times 10, 10 times 10 is 100, variable plus 5, or 10 plus 5 is 15. And this is like the basics of creating variables and using them later in the program. And then so in class 4, we learned about the Boolean expressions. So a Boolean expression, to put it simply, is a true or false. So it's either correct or it's false. So in this instance, we've declared a Boolean variable instead of some integer variable over here, which is that 1 is less than 3. So since 1 is less than 3, the Boolean variable called value will be equal to true. And then we can actually use these Boolean variables to do something called selection. So if some variable is true or some expression is true, we can run the code in the block. Otherwise, we can skip the value, skip the code running the blocks. So this is going to be important when you want to run a certain block of code only in a specific circumstance. So you don't want it to run every single time, but only when a certain condition is being met, or certain condition has been met. So in this instance, since value is equal to true because 1 is less than 3, if value is true, this is basically what this means. I'm going to run this first code right here, so it's going to print true. So all this to say that after all these 10 lines of code, sorry, well, like 7 lines of code, it's going to print out true. Does that make sense? Or does everybody need me to go over the Boolean stuff? Because this is actually pretty difficult to understand. Maybe I can like type in the chat or just unmute or give a thumbs up or anything like that. Just so you guys know, if there's any like anything here that you don't really understand, I can help explain. Okay, so I think that's good. So I think that's good, then I'll move on into motivations. So what is a loop, and then why do we want to use loops in our program? So suppose that you need to print out a string. Programming is fun 100 times. You're not gonna, the conventional way to do that is to write the print statement 100 times, but that's gonna be tedious to write. And also it's gonna be hard for you to read, hard for you to debug, hard for other people to come in and help program along with you. So it's just, basic etiquette, or you would say it's just more efficient for you to use a loop in this case. instead of writing 100 lines of code. And then you can imagine if instead of 100 times, you want to print out 100,000 times, then it's going to get extremely like large, and it's just going to be overall better for you to use a loop. So conventionally, without using loops, we're just going to use print statement. Programming is fun 100 times. 100 lines of code, each line is printing this. But the solution instead, using loops, is simply four lines of code that will print out programming is fun 100 times. So we can break down more what this is in the future once we're tracing it, but I'll give you like a basic overview here. So we're going to create a counter variable here that's going to count the number of times or what number we're currently on. And then while this Boolean expression, right? So these loops all use Boolean expression. So while count is less than 100, we're going to print this programming is fun. And the important thing to remember is that after every single time you need to increase count by 1. That way you're like signaling the program that, yeah, you've done it once. You gotta add another one. That way let's run the second time. So to explain this better, we can use like a flow chart. So you guys don't have to like know specifically what does what here, but basically while some condition is true, we're going to execute the loop body, which is just full statements. So in this instance, count equal to 0 is outside the loop's condition. So count is going to be set equal to 0 before we even encounter the loop. And then while count is less than 100, we're going to run these two lines of code continuously. So you're going to trace it so that you guys can understand it better. So first we're going to initialize count. Second, while count is less than 2 is true. So while 0 is while this condition count is less than 2, we're going to run the program. So currently count is on 0, and since 0 is less than 2, it's going to be true, and we're going to run the while loop. And so what that means is going to go through the first statement, print welcome to Python, or sorry, programming is fun. And we're going to increase count by 1. So it's important to note that now count is not 0 anymore, it's 1. So when we go back, we're going to reevaluate the condition. But since 1 is still less than 2, this count is true, and we're going to run again. So we're going to print programming is fun and increase the count by 1. Okay, so now go back here. Count is 2 now. So we're going to go back up into the while condition. So while 2 is less than 2. Now 2 is not less than 2. 2 is equal to 2. So this condition becomes false. We're going to skip this next iteration. That means we're not going to run the code again. And instead, we're going to exit and go on to the next code. So here's a general caution. So the main thing is if you guys remember back to the first couple lessons, I talked about floating point imprecision. So what this means is that whenever you're some computers can't really represent decimal numbers super accurately. If you're using some really small numbers, it gets hard for the computer to store that correctly. And what ends up happening is that the computer instead of like, so for instance, here's the example in the code below. I'll explain this one later, but basically since the computer can't store it correctly, it will use an approximation instead of the exact value. And so while on paper mathematically like 0.1 minus 0.1 is equal to 0, in the computer that might not be the case. So consider the following code, which is computing 1 plus 0.9 plus 0.8, blah, 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 0.1. So the item is 1, so we're starting at item of 1, and the sum is some number 0. So while item is not equal to 0, so while we haven't gone to 0 yet, we're going to subtract an item every time by 0.1 and add that to the sum. So eventually, logically, if we keep subtracting by 0.1 from 1, we know that 0.1 minus 0.1 is 0. So this while loop in our heads should exit. However, since the variable item starts with 1 and is reduced by 0.1 every time the loop body is executed, the loop should terminate when the item becomes 0. However, there's no guarantee that item will be exactly 0 because the floating point arithmetic is approximated. So instead of 0, you might have 0.000000001 or 0.000001001 or something like that. So basically, like it's not going to be exactly 0. It's going to be some small number. And because the floating point arithmetic is approximately 0, there's no guarantee that the item will be exactly 0. And this loop seems okay to us, but if we actually write this, it's going to be an infinite loop. So you need to watch out with infinite loops. If you forget to increment your counter, or if you use a float variables, you can make something in your code that runs forever and doesn't ever end. Okay. Now I'm going to show a different example of a for loop. So a different example of a loop. So instead of a while loop, we have a for loop as well. So these two are pretty much the same thing, but for loops are better used when you know the exact amount of times you need to run something. So for instance, uh, like how many like find the sum between numbers 1 through 10. Like you know that you only have to sum up the first 10 numbers, but while loops are better if you want to just evaluate a condition just like by itself. So like while some unknown number is like less than some other number, you can use a while loop. But for loops, it's better to use for loops for like looping a certain amount of times. Like you know what that number is. While loops, you use it whenever you don't know what that number of times is. Sorry. So the reason why we want to use for loops for a specific number of stuff is that remember in the while loop, whenever we were tracking everything, like we had a bunch of extra code, like we're initializing the control variable or the counter variable. And then at the end of the while loop, you have to remember to increment the variables so that you don't get stuck in an infinite loop. The for loop does all of this in the one line of code and makes it just a lot more easier. So for instance, instead of using this, initializing it here, we can do for I in range initial value and value. We can execute the loop body. So what this does is by using this for loop, we're automatically after every single time we finish this loop body, it's going to increment this value of I, this variable of I. And secondly, we don't ever have to declare what I is. It's just a temporary variable that the for loop creates. So you don't have to initialize it. And if you do initialize it, it's going to be this initial value of range. It just makes it a lot more simpler to just write and read. So let's dissect the second part of this for loop, which may be quite new to everybody, just the range between the initial value and end value. Okay, so let's give it an example. So for instance, for this for loop, so for v in range 4 to 8, we're going to print out v. So remember, this first one is the initial value. So v is going to start off at 4. So we're going to print v in the beginning, it's 4. Remember, this for loop automatically increments v by 1, so v becomes 4 plus 1 or 5. And then that's going to plus 1 plus 6, plus 1 becomes 7. And then remember here, it's an important thing to note, the range, the end value is not inclusive. So if we wanted, so this, once v becomes 8, it's not going to run this last one, even though even though we say it ends at 8 here. So if we actually wanted to include 8, we'd have to make this 9 or something else. Okay. Yeah. So that's the range of two functions. Another trick you can use with the range function is if you want to start at 0, you don't have to write the initial value and value. Instead, you can just write the end value here. So in this instance, for I in range of 4, this is just the end value. Like for the for loop will automatically assume that I is equal to 0. So I in the beginning is set equal to 0, and then becomes 1 when you add 1, and then 2, and then 3, and then it doesn't print out 4 because remember, uh, the range is not exclusive. Sorry, its range is not inclusive of the endpoint. Then the third way you can do this is actually pretty interesting, is the range A, B, and step. So once again, it's going to be a start and the end, and this is actually a step variable. So instead of incrementing by 1, you can actually increment by more numbers. And so one example is this is for V in the range of 3 to 9 exclusive, so you're not including 9 here. I want you to add by 2. I'm going to print V. So remember, V is the initial value of 3, so to print that, we're going to do step by 2, or 3 plus 2 be 5. So if V is equal to 5, I'm just going to print that out. And then 5 plus 2 again is 9. Sorry, 7. Print out 7, and then 7 plus 2 is 9. And remember, we end at 9 and not including 9, so we don't print out 9 at here at all. Okay, so that's that. And then also, using this same format, you can actually count backwards. which is pretty interesting here. So for a v in range of 5, so starting at 5, ending at 1, and then stepping by -1. So we're going downwards this time. You're gonna get 5, 4, 3, 2, and then the 1 is still exclusive. That's just a neat and tricky way to use the range values, guys. So just you can mess around with the conditions. Just makes it a lot more simpler. So yeah, here is an exercise. So write a while loop that'll print out your name 10 times. So I'll like wait a little bit, and then I'll just do this one. Okay, and then so I'll probably do this one. So write a while loop that'll print out your name 10 times. So if you remember in the beginning, for a while loop, you need to do a counter variable to keep track of how many times you've done it already. So in the beginning, we haven't done it any times, so counter is equal to 0. And then to actually write a while loop, you need to do while some condition and then a colon. So in this condition is going to be while counter is less than 10. Okay, and if you're asking like why it's not less than equal to 10, remember we start at 0. So whenever you start at 0, the way it happens is that you're actually going to add 1 to this automatically. So yeah. Okay. Hello, Julie. You just joined. It's okay. We'll have the recordings posted, but we're currently just on like an exercise. I'll go back and teach some of the stuff. So for this exercise, it's using a while loop, which is something we just learned earlier today. Print out your name 10 times. So this is a Boolean expression, so while counter less than equal to 10, sorry, less than 10, to print out my name, which is Ethan. And then I'm going to increase counter by 1. Not counter. Okay. Okay, and what's going on here? Sorry, it's a bit slow today. Okay, that one's the assignment. And another thing to do is if we wanted to use a for loop and instead, I could write the same code using the for loop, which is a lot easier. So for I in range 10 to print. So this should do it 20 times because the second code also prints out my name 10 times. Does that make sense? Okay. Julie, do you want me to go back and just review like the while loops for you? Or like there's no point going forward with another sign. Okay. So just the reason why I'll start with the reason why you use while loops, right? If you're going to try to do something like 100 times like 100,000 times, like print something 100,000 times, that's going to be quite tedious, and we don't want to just copy and paste this line 100,000 times. For example, we want to write a loop. So here's what a loop looks like. So this first one we call a while loop. So while this is a Boolean expression. So while this Boolean expression is true, we're going to run this code. So let's break it down. You don't really this one. So let's trace it. So we're going to use a counter variable. So count is equal to 0. This one keeps track of how many times have we done it already and what number we're on currently. So counter is equal to 0. So while count is equal to is less than 2. So since 0 is less than 2, it's going to be a true, and then we're going to run the while loop. And we're going to run that by first printing welcome to Python and increasing count by 1. So instead of 0, count becomes 1 here. I'm going to go back into this while loop. And since 1 is less than 2, and that's still true, I'm going to run this program again. I'm going to print programming is fun. We're going to increase count by 1. So now that count is 2, we're going to retry this while loop. So is 2 less than 2? No, 2 is not less than 2 because 2 is equal to 2. So we're going to exit out of this while loop. I'm going to run the rest of the program. Another thing to be cautious about is make sure you're always updating your counter variable correctly. So if you, for instance, did not have this line of code here at all, count would never be changing and count would always be equal to 2. So instead, you're going to generate something called an infinite loop. So programming is fun. You're going to print that an infinite amount of times. And another cautious thing you do is remember that while loops work best with integer values. So if you remember back to lesson 1 or lesson 2, we talked about floating point imprecision. And so what that means is that super small numbers or decimal values, even if you subtract their equivalent, like they're only approximations. So 0.1 minus 0.1 might, we know it's 0, but the computer will give you an answer somewhere like 0.00001 because these binary numbers, like these decimal numbers, are represented using approximations, so you won't get the exact results. So we have like an example here where we're starting at 1 and we're subtracting by 0.1. So logically, if we keep subtracting 1 by 0.1, we're going to get to 0 because 1 becomes 0.9, 0.8, 0.7, 6, 5, 4, 3, 2, and then the last one right here, 0.1 minus 0.1 should give us 0. So this while loop should exit because if an item becomes 0, this will be generated to false, and we're going to exit. Right, but if you actually write this and code this program into the compiler, you'll notice that this is an infinite loop because there's no guarantee that this variable item is actually 0. It's going to be some value like 0.00001 or something small like that. So just be careful. You use integer values. Try not to subtract by decimals. Does the while loops make sense? Are you understanding the while loops? Let me know if got like type in the chat or something. Well, she left, but that's fine. Let's go back to the second exercise then. So create a while loop that will find the factorial of a number. I'll give everybody some time to look at that. Okay, so let's look at how to do this problem. So important to remember here what a factorial is. So factorial is if we have 5 factorial, which is denoted by this exclamation mark, you're simply finding 5 times 4 times 3 times 2 times 1. Okay, and then similarly, 3 factorial will be equal to, sorry, 3 times 2 times 1. So you're basically finding every single number multiplied by 1 less of its previous number, and it doesn't include 0. So we have to try to find this. So given some number, we're going to first declare a number variable. Let's just say 5 in this instance. I'm going to use a while loop to find the factorial. So we create a counter variable, remember, equal to 0, because currently, actually, we'll do this. So in this instance, counter is going to be variable set at 1. Because we do not include 0, we're going to start counter at 1 and sum of 1. So this is what we're multiplying it to. So this is what the factorial is going to be. Let's name it factorial, actually. So while counter is less than 5, right? Remember, we need to increase this by 1. So basically, while counter is less than 6, because we want to include the 5, want to factorial multiplied by the counter variable. And then important to note that we have to increase counter by 1 so that we don't run into an infinite loop. Then we're going to print out factorial. Run this, give us 120. And so that makes sense because 5 times 4 is 20, times 3 is 60, times 2 is 120, and then times 1 is 120 still. Okay. And then we can try to use a for loop for this. So if we set counter, sorry, set factorial back equal to 1, and the for loop for I in range of number plus 1. Sorry, it's probably best to do like this does the same thing. The range of number plus 1 going to factorial multiplied to I. Okay, no worries. I'm just doing the second problem. We're using for loop here. I'll go back and explain this one later. Okay, so now let me start at 1. Yeah, remember you don't include 0 in the factorial. So where did you end off? Did you like when did you leave? Did you get to the while loops? Or was I mid explanation, or did you, where did you get to? Uh, did you finish the while loops? Page Q6, page 16. This one. Okay. Okay, yeah. Sorry. So let's see where we're at here. I'll go back and redo the tracing. So I remember count as 0. We went through this entire while loop, and since 0 is less than 2, we're going to increase count by 1. So count is 1 now. I'm going to reevaluate this condition. So 1 is less than 2. So since 1 is still less than 2, like we're not done looping yet, so we're going to continue to loop. I'm going to print out programming is fun, and I'm going to increase count by 1. So now, since count was already increased by 1, and we're increasing 1 by again, count is going to be equal to 2. And so since 2 is not less than 2, this condition becomes false. So we're done looping now. And we're going to exit the while loop, right? Does that make sense? And then here's another caution thing. You need to remember to iterate correctly. So you have to update your counter variable every single time. Otherwise, you can create an infinite loop. So for instance, if this count variable, if this line didn't exist, count is never going to be updated. It's going to always be 0. So this while loop is going to print, while loop is going to print programming is fun, like an infinite amount of times. Okay. And then so also make sure your counter variable is an integer, because if you remember from the first couple lessons, we talked about floating point imprecision. So what happens is that it's just an approximation of a decimal number. So in this one specific example, if we keep subtracting by 0.1, it's not guaranteed that it will equal zero, even though mathematically, like we as humans know that if you keep subtracting 0.1 from one, like at the end here, the last step, which is 0.1 minus 0.1, is going to equal zero. The computer stores it differently and uses an approximation. So whenever the computer reaches this step, 0.1 minus 0.1 might equal 0.00001 because it doesn't like hold the values correctly. Does that make sense? Did you understand while loops, or do you need me to get back into? Okay. The next part is a for loop. So for loops and while loops are pretty much the same thing, but we prefer to use the for loop for if we know like how many times we want to do something. So for example, in this instance right here, we want to print out programming is fun twice. It's actually preferred to use the for loop because it's just a lot easier to read. And people use while loops if they don't know how many times we should run something. So you can take a look at the while loop again, how it works. You need to create like initial value, you need to increment the variable, and you need to have the loop body, etc. But for the for loop, you have this one liner, which is the for loop declaration, and then everything else after that is the loop body. So you don't need to write these extra lines, which can just clutter up your code. So to break down what this means, is that this for loop, it just instantiates a loop much like this while does. And so while I is less than the initial value and end value. So while I is starting at the initial value here, which can be zero or a billion, whatever value you decide. And before it ends here at the end value, it's going to loop this body loop this body that many amount of times. So that might not have been too clear, but we can go through some examples. So an important thing to know is that there's a range function here. So let's dissect what that is. So this first one is the starting condition, and the second one is the end condition. So if we see this example code right here for V in range 4 to 8, remember we're starting at 4 and we're ending at 8. So we start at 4, we're going to print out 4. And then this code automatically updates V to increase by 1. So V becomes 5 without having to write the extra line of code. This for loop automatically does that for you. That's why it's a lot easier to read, etc. So it goes from 4, then 5, and it's going to increment again to 6, and then 7. It's important to note here that this 8 here is not inclusive. So if we write this 8 here, it's not going to print out 8. If you wanted to print out the number 8, you'd have to increase this one more to become 9, because at the end here, it doesn't include this in the range to print out. Does that make sense? And then there's more examples to clarify it further. Or do you need me to explain some other parts? Or okay. Okay, and to simplify it even further, if you're already starting at 0, you can just put in the endpoint. So instead of putting like range of 0, comma b, you can just put in range of b, and then it'll automatically start from 0. So for I, this variable I is a counter, starting at the index of 0 and ending at 4, it's just going to print out 0, increase by 1, print out 1, increase by 1, print out 2, increase by 1, print out 3. And then remember at the end, when increase by 1 becomes 4, it's going to terminate the loop, and we're not going to print out 4. Does that make sense? Okay, so it's pretty much the same thing, just if you don't have to pass in 0. If you don't pass, if you only pass in one thing, it's going to automatically start at 0. So another cool thing you can do is you can actually pass in 3 values, and this third value becomes a step. So normally in these two functions right here, the step is 1, right? We're increasing 1 every time, right? Starting at 0, increase by 1, increase by 1. That's what we call a step. But over here, you can actually create a custom step variable. So you don't have to step by 1. So for V in the range of the starting at 3, ending at 9, and then increasing by 2 every time, we're going to print out V. So V starts at 3 plus 2. It's going to run this code, print V out, and then add 2 to it. Becomes 5. 5 is less than 9, so run this code again, print V. And then at the end, we're going to increase by 2, becomes 7, which is still less than 9. Add 2, print that out, add 2 becomes 9, which is not less than 9. It's going to end there. So we're going to print out these 3 things. It's not. Okay. This one's pretty self-explanatory. And then you can actually do something cool with that, which is you can make it -1. So you can actually, instead of increasing, so from going 0 to 5, you can actually go 5 to 1 or 5 to 0. You can go backwards in a sense. So the step would be, instead of adding 1 every time, we'd be subtracting 1 or adding a -1 every time. So we're starting at 5, ending at 1. 5 minus 1 becomes 4, minus 3 becomes minus 1 becomes 3, minus 1 again becomes 2, and then finally 2 minus 1 becomes 1, and we're still not including the end, so it executes. It's like ends the loop after this. Does that make sense? Okay, so this exercise 0 was the first one that we did. We'll just write a while loop that'll print out your name 10 times. So here, let me tab out. Okay, so I'll just do that one quickly to show you what it looks like. So counter variable, remember, to keep track of which one we're on and how many we've already done. So while counter is less than, since we wanted 10 times, we can click 10 here. And important to note here that we say less than 10 and not less than equal to 10, because if we set counter equal to 0, it's already going to factor in like 0 to 10 is already 10 times. Otherwise, you're probably thinking this one is maybe a little bit more intuitive. So we're starting at 1. We could do something like this instead. But either one of these is just going to be run it 10 times. And we'll print out Ethan. And then also remember to increase your counter variable by 1. So print my name out 10 times. And then you can use the for loop still. So for I in range of 10, print, sorry. So if we deleted this one, all this code, you can write all that in just this line, and then it'll generate the same output. Okay. That's pretty much it for this one.